And Standa? Yeah.
Good afternoon, everyone. I would like to thank Pauli for a nice introduction of our company. And I would like to continue with a presentation about how we switch our code from some legacy stuff from history, from beginning of our startup and Skypicker. We need to do a lot of stuff to move our code to something like modern code. My name is Standa, and I'm currently finishing my PhD from biomolecular chemistry. And I also was teacher for Python courses at the university. And now I also work for Kiwi, like Python developer. I work in check-in team, which is focusing on automatic processing of your check-in. If you buy some flight at the Kiwi, we provided some automatic check-in, and this is my responsibility or responsibility our team to provide you the boarding pass. This means we focusing on some processing, planning of the check-ins and this stuff. Sorry, I need to be synchronized. Okay, what is legacy code? For me, is that the code when I need to go hard to understand the code, hard to adding a new feature or new things to the code. For our code base was mainly the old technology that we use still Python 2.7. We have also had problem with testings and long and understandable code. This means we have some spaghetti code in our code base. It was very hard to understand what is there. We also have problem in monolithic code. This means you mixing the functionality, for example, business logic, with some operatives, loading data from database, and it's hard to divide this part and find what is the important for the code. Also, we have repeating things in our code base. This means if you try load, we need to save the boarding passes on the cloud storage. It has happened that in our code base this code was repeated more times. I count with 5 times. And we need to solve this issue that, for example, if we need to change cloud provider, we need to change code on the 5 places in one. Okay, what can we do with this code? We have 2 possible ways how we can solve this problem. One thing is the refactoring, that we take the old code and we try to rewrite step by step and try to fix this issue. And we have also possible way that we rewrite all code from scratch, from beginning. We tried to go with writing from scratch, but it's not good for our manager. And the reason for this is that in many company or when you have some service in your company, you need to provide the service for your customers or for other department, and you cannot stop this service and start work on something new, because it's take a long time. If you just looking what say Tom Carlick, that the first percent of the code accounts for first 90% of development time. The remaining 10% of the code accounts for the other 90%. This means it's totally 180%. This means finishing the project is very hard, because at the end, it seems that everything is working, everything is fine, but still you have some bugs, some issue with your code, and you need to solve it. Okay, most important thing when you go to the refactoring, it's team. When you have team of developers, you need to count with this that every person in your or every developer need time to learn new things. We struggle with this a lot of because we have something called learning curve. That when we start, we are clueless and we don't know what can do. We're starting by step rewriting some function, and we think that everything is okay. But everything wasn't okay. We are struggling with problems in our code. This means the service doesn't work for some time, or some specific feature doesn't work. And this problem learn us that we need to know the service, because when you didn't know everything, every aspect, it can happen that that you forgot about something, and you can easily broke your service. We have, I call it 3 stages of our refactoring. First stage is where we get to know the code, the functionality. Then we move in stage that we are able to understand the code, and we can switch to Python, upgrade to Python. And now, currently, we are in stage 3. They are ready for bigger changes, and everything will be better. Or is better. The first stage was very hard for us, because I call it dark age. We have struggling with this problem that our service not work properly. It's mainly, the problem is that we have few tests in our code, and we added some of the test, but the ugly test. We don't understand correctly what we're testing, and we need to improve metrics and logs, because sometimes we was blind and we don't see the problem in our code. Second stage was some relief for us, because we say now we are ready to upgrade to Python 3.6 because of the salary. I talk about this later. And the transition to new Python version was very smooth, because it takes 1 week. We use some automatic tool to catch the syntax difference, and we have a lot of tests, we have monitorings, and when we switched, everything works fine for us. This was great for us, but it takes a long time to prepare it for this, and a hard time for us. Now we are in the stage 3. We are preparing for bigger changes. We try to break the monolithic code that into single-purpose packages. We are ready to write better testing, and also we try to use pair programming and prototyping that can help us to develop our technical experience. Okay, what we need when we look back, we can summarize what is important for this for the refactoring or for the big change in your code. Beside the team, you need to have monitoring, alerting, and testing. This is most important to know if it's something broken in your code. If you push in your master something what change or broken your service, you need to know about this. Also, you need to have strategy, how you can go in the future, what is your plan, how your code will be look. And also I will speak about the testing, about the tools, pair programming and this stuff. Okay, when we looking on the monitoring, alerting and testings, most important here is the monitoring. If something happened, we can push, we can send some numbers that we, for example, process this check-in, this number of check-in, and we are also check if everything is upload our cloud server and this stuff, and we can check if everything is in normal, and if not, we can connect it to alarm, and this can notify us about the problems. Also, here is place for test, because if you have good test, this can prevent the breaking the code before you publish or before you deploy to the production. When we looking on the monitoring, we use Datadog. It's a simple tool that you can push the metrics. Basically, you can add some value, adding a value or decrease value, or send some numbers. For example, here you have some memory that you can push every 5 minutes information about memory used for your service. You can also measure some time, or if something happened, you can increase some metrics, and you can see how it's here you have some timeline that you see how it's working in the time. Beside of the monitoring, I skipped the test because, skip the logs, because logs are mainly for finding the bugs and this stuff, but also important. But most, I would like to say that the tests are more crucial for this type of refactoring. You can have ugly tests. We have a lot of ugly tests. That means that we need to mock everything. It's hard to mock something, and if you have complicated code, it's hard to write tests for this complicated code. Best way how to do it, it's write test and then you write code, because you do it hand to hand, and everything can work properly. What was problem in our code was that we have some evaluation which came up when you initialize. For example, we have class booking, and when you try to initialize, you also get the reservation, and this reservation makes some call to API or call to database and load the data. And this is hard to mock. You can use the lazy evaluation that you can use bolt-on cache utilities for cache property. This means you have booking. When you initialize the booking, nothing loaded. You don't have reservation in your instance. But if you call the reservation, it works like property. You call the function get reservation, and in this moment, you are able to receive the reservation. It works same, the code works same for both. The difference is here that you can define or use attribute injection, and in test you can say that when you create booking, and booking.reservation is equals something, and you can replace the value, and you can skip the loading from database. The cache property here works that the cool feature about cache property from Bolton is that this is evaluated only for first call. This means if you create instance of booking and ask for reservation, this cache property call get reservation and save the result from get reservation. And if you ask more time, you already receive the result from first call. Be aware of code execution during the imports. This was most painful thing in our code base if you have something that is called during the import. If you have some code in it and in settings, it can happen that you need to mock a lot of things and your code and when you try if you try load something from your code base, it can happen that, for example, load the database, ask for some credentials or ask for some secret, and everything is done when you try to only import something in your code base. PyTest fixture with auto-use true are evil. We try from beginning to do this because when you have some ugly test, you need to do a lot of fixtures and try to use auto-use. And when we try use or prepare some more better test, it's happened that we are in collisions and was hard to find the bug or the problem in test. Also, dependencies and singletons are evil because if you have two packages which are connecting together, and one class creates some other class, it's also hard to find a problem. Now we can move to next part of refactoring. That is strategy. For us, we can think about this strategy like documentation. Some document when you write what do you think that you need to do. Some planning and this stuff. We try to split the code based on the functionality and also use some design pattern. I show you now what we used and what I think that is most useful for you. When you have monolithic code, you can have something like core, utilities, and this basics or general name in your code, and it's hard to find what this does. Yeah, if you look on the core and when you look on our code, you can see that this code basically do everything. You cannot split it, you cannot find what you can test it in this code, and it's also hard to explain what the file do. We started with single purposes packages, for example Wallet, which is responsible for working with boarding passes. You can save the boarding pass in Wallet and you can ask the Wallet to get the boarding passes. Simple functionality for this small package. Also we have designed the settings which hold everything what we need to set up our application. And here you have example how look like old code base. If we moved, you can see that we have specific package, and this specific package has this package has one purpose. Okay, if you have packages and you need to connect it together, it's a little bit tricky. Because when you create, for example, when you create Wallet, it can happen, you need to know about settings, database, and this stuff. And great way how to solve this problem is the dependence injection that allow you create the instance of this dependency outside your class and insert it in your class when you need it. We have Wallet, which required some booking ID, settings, database connection. And this is dependency injection because we injected these dependencies in our classes. And if you try to use Wallet, you need to initialize settings, database connection, and then you can use Wallet. Maybe you can, when you look on the screen or the slide, you can find this is so complicated. You can basically call Wallet and You can initialize the settings and database connection inside the wallet. But problem here is that it's hard to test. We can in this code, we can simply create some dummy settings, dummy database connection, and inject in wallet and use it in the test. This means you can easily test the functionality of the wallet. If this can happen because duck typing, because here you have settings and database connection in definition, and the Python count with this that this object have some methods, some attributes, and if you create something like dummy settings, you can define this method and attribute, and you can inject it, and everything will work correctly. No, not correctly, but you can test it by this approach. Okay, and our main goal is create something like monorepo. This means we can connect it together, these packages, in different way, and create different application. For example, we have project that we try to read barcodes from boarding passes, and we found out that some open source implementation in Java can help us. And for this reason, we can create specific image which contains only Java and Python, and we can create this small package, a small image, and deploy it to the production. And when we go back to the tooling which we are using, we're starting with agile development. This means we start to plan our work in short time. We have some plannings, estimation, and help us to thinking like team about the problems. Also, we required code review for our code. This means I'll show you later. Pair programming and research and prototyping. Code reviews. The main reason why we choose the code review or why the developers like the code reviews is that you can improve the code and developers' knowledge. You can also expose some issue in code. Yeah, because other developers have different ideation or different view on the problem and can come up with better solution or can ask some question which can lead you that you forgot about something and you need to fix before you release it. If you prepare merge request or pull request, it's great that you're thinking about it. If you create small merge request, small as possible, and you describe what you try to solve and background about this problem, it can help the reviewer to process your review in shorter time. It's often happen in our team that when you create big merge request, it's stay in our repository in a long time, and it's hard to push to my colleague to approve my merge request. How you can also improve merge request is that you have a great continuous integration. This means this can help you to improve your code. For example, we have Black. If you don't know what is Black, it's strict formatter for Python code. I would like to suggest to try it, because if you write some code, you can use little bit different syntax in Python. You are limited, but you can use different syntax. And if you use the Black provide you the nicer version, let's say, or unified version of your code. And this means if we use in the whole company this tool, this means that every code have same style. And it's great if you, for example, change the team and you are able to read the code better if everyone use same syntax. And also you can use, here you can use code pairing. If you have some bigger changes in merge request, you can sit with your colleague and you can discuss what you try to solve. And it's great because it's in short time, you can improve the code in a big way. I love this because when I have something when I try to solve some problem, I can try. I need to solve focusing on the solving of the problem, but sometimes I lose other aspect of the solution. And when you sit with your colleague and discuss it, it can help you. Okay, this is example how we use Gitlab, that we require the approver for every our merge request. And last thing is prototyping. It's a great way to try new shiny things before you try to implement in production. It's we can start with example. We have some problem with concurrent task. We are using Celery for processing our asynchronous task, and it can happen that two same tasks running in same time and work with same data. What I would like to introduce the Celery and SQL Alchemy, what will be showing in example in next slide. Celery is basically distributed task queue. It's some big gun to process multiple tasks, different tasks. This means you can create definition of task, and then you can run it multiple times with different parameters on in parallel. You can also create some periodic task in Celery and run every task every hour, for example. We use it, for example, for monitoring, that we, for example, try to check our database every hour and do some select from database and to find and check if everything is okay. SQL Alchemy is Python SQL toolkit and object relation mapper, which can allow you easy work with database. You can create the model of your table, and then you can query based on these models. Where is the problem? This is prototype. This means I was able to create this prototype in, let's say, 10 minutes, and it simulates the problem in our code base, which is much complex, and you contain more and more different things. Problem is here that you have you define Celery application, and you create task, and this task you can call it like this. This means you can use apply sync or delay and send this task on the worker, and you can push a lot of tasks in your worker, and everything will be in a queue, and Celery will process task by task and help you to do a lot of things. Here, when we run this same concurrent task in this code, you can see that we just looking in the database, select some data, then we need to send the data to another microservices in our company. Then here is some information about what we send it into microservices, and then we update task if everything go well, and we properly informed other microservices. We update the status, and we set to database. Here, the check-in is model, which contains the information from table, and you can, for example, check-in contains status, and you can simply change the status, add it to the transaction, and commit this transaction and save in database. Problem is here. If you have two concurrent tasks like this, and you have two tasks, which one try to change this and this, you run two tasks, and first return to the next to the another microservices processing and waiting for details, and second task rewrite with waiting for details and processing. This means the other microservices now have saved these statuses. And this is wrong because we have processing and processing in our database. We try to do like this, that we have one task which processing and waiting for details, and next task will able to use processing from first run and then change the second status. Idea about how we can solve it was use database log. If you go to research, you can find Postgres that use select for update, and in SQL Alchemy have with for update. And you can simply try in your code if it's something change it. If you add this in your code, run the prototype, you can see that everything now works correctly, because this wait for select and update first select locked these rows, and the next task waiting for update from the first task. Okay, this is sharing of idea in GitLab. You can see that you have prototype in your repo, and you can share the ideation and solving your problem. You can discuss with colleague how you solve it, what is the aspect solution, and other stuff. I would like to conclude my talk. Don't forget about metrics, alerting, and testing in your project. Also, if you try do some small project, it's great. Do some monitoring, some simple monitoring. Try it. Strategy. It's teamwork that you try to design your service. Tools are great. Try to use some prototyping when you learn something new, because it can help you to solving problem and thinking about how you can present to other people. And if you're working in a company and we have colleagues, try to ask about the code reviews. It can help you to improve yourself or the colleague. We can sit and discuss the problem. And this is everything from me. Thank you for your attention, and any questions are welcome. No question?
Thank you. Excuse me, my English is not good, but I will try to do my best. You talked about the continuous integration in your talk, but what's happened with the continuous deployment? Did you use continuous deployment?
Yeah, we use it, continuous deployment. This means if you push something in master, make the merge request, will be merged. You can push the button in GitLab and deploy the image in the production. In Kiwi we have also software which is called Crane, is open source, and you can use it for deployment image to the Rancher. If you use, for example, Rancher in production, we have some tooling that allow you to push the image from GitLab CI to the Rancher, and you can.
Please let me understand how do you work. Do you use these code reviews? And if, for example, if you have a change in the code, you launch a code review to your colleague, and your colleague approve the change, or I'm right? Yeah?
Yeah, I talk about this. This is required for us. You need to wait for approve, and after approve, you can merge it. This means the code review waiting, that the merge request waiting for approve. After you have received the approve, you can merge it and push it in production. It's answer for a question.
One more question, please. Because I would like to know how do your team make code reviews? For example, it's very interesting thing to know how to make a good code review. For example, when I was in my country, I'm from Peru, my previous team make bad code reviews. For example, they make some comments on, or something like that in order to apparently making a code review. But, for example, my current team make good code reviews. But I think it depends on the team. But how do you deal with that problem?
This is a great question. I think about this problem is about another presentation. But in short, I would say that we have discussion about this in our team, and we agree that code reviews are same important that writing the code. This means you need to prepare some time for code review, give the time for code review, and do it well. Do it well, yeah.
I do have one, a quick one. After code review, do you follow up with a QA or acceptance tests?
Yeah. The problem is with people. We're starting arrange our team bigger scale, and we have only one QA for long time, and it's hard to test everything. But with working on new process, and I hope that this will be also part of the process of deployment of new things.